Hi, everyone, and thank you for joining today's webinar. My name is Mark Silverberg, and I'm a Customer Success Engineer here at Domino Data Lab. I'm really excited to talk to you today about how Domino enables organizations like yours to incorporate and use open source tools for data science and quantitative research work. And with that, I'm going to get started. Again, you should be able to see my screen. I've got a title up here, and we're going to get started. Perfect. So I work with a lot of customers, both with using Domino already and getting started. And the problem I hear with that I hear from customers that are just getting started is that the problem they have is that it all revolves around large organizations having a hard time not just evaluating or developing, but also deploying open source stacks such as R, Python, RStudio, Jupyter, Anaconda, Shiny, H2O, all of these open source stacks. Their organization is just not set up to move fast and to install these applications. And so the truth is that these tools are actually not meant to be shared in the way that they're currently trying to. They're meant to be downloaded by an individual on their desktop. And sometimes IT will come in and install these tools on a server and give members of the team access through remote desktop or a shell tunnel. But this leads to a suboptimal experience for data scientists and IT, who is now in the business of keeping up with the latest trends and basically upgrading every other week when the open source project ships new code. Furthermore, the process of installing these applications and codes on each computer or on a central server is just not scalable, and it lacks the infrastructure and stability to truly support mission-critical contribution to the bottom line by the data science teams. And this is all on top of the fact that while some open source projects do have a community of vendors offering enterprise support, it ends up putting the burden on your organization to string together multiple enterprise versions of open source software into a difficult to manage homegrown mess. And so that's where Domino comes in. Domino is, so I want to introduce how Domino is being used inside of organizations like yours today to take open source tools and use already in use and desired by organization and bring them outside of silos, greatly reduce the need to have expensive enterprise support contracts, and give people a real first-class way to interact with your existing large infrastructure, utilizing the tools they already want to use, not just the ones that they have to put up with today. And so Domino is a software application. It gets installed on the infrastructure of your choice, so either servers you already have or a virtual private cloud such as an Amazon, and it allows you to run all of these tools in a secure and unified experience. And Domino is a bit unique in the data analytics space because we actually choose to embrace the existing and largely open source data science ecosystem that already exists today. In Domino, you can use all the tools you want to use today, combined with the data wherever it might be, on top of the code systems that you want to use as well. So we've got R, Julia. We do support proprietary systems like SAS and MATLAB as well. You could bring your data in from Hadoop or Spark or flat CSVs or Redshift through a VPN, for example. And of course, your data scientists are already using RStudio, Jupyter, perhaps Plotly and Knitter and R Markdown, and scikit-learn and H2O. I'm going to show you how this works in practice in a demo in a second, but I want to first give a few notes on the 5 core pillars of functionality in Domino here in the middle of the screen. And so first, we have compute automation. Domino automates the efficient distribution of compute jobs across whatever servers you make available to the Domino cluster. So if you're running Domino in Amazon Web Services, for example, we make it easy for you to try your code on a small server like a 2-core, 8 GB RAM machine, or on a 128-core, 2 TB RAM beast, the X1 instance from AWS. In terms of environment management, we run your code in a consistent and isolated environment, so you and your users don't have to worry about DevOps. We allow users to install anything they want inside this custom environment, which can be shared either globally or to specific users. So for example, one team could use the bleeding edge version of TensorFlow on Python 3.6, while another team runs legacy code on Python 2.7. And by just using Domino, everything is version controlled, not just your code. We version control model input, code, data, results, and compute environments so you can have the confidence that you'll be able to go back and run the same model in 6 months, whether it's for an audit or to reproduce your research for publication. And with everything stored centrally, you can invite collaborators and discuss results in a secure environment integrated with your existing Active Directory or LDAP group management, so you don't have to remember yet another password. And finally, we provide ways to operationalize and put your work into practice with other systems through easy deployment of API endpoints and apps like Shiny and Flask, so that your data science work can be shared and you can impact the whole organization. So now I'd like to actually show you how this all works in Domino, and I'm going to switch over my tab to Domino in the cloud. Awesome. So your first entry point into Domino after you log in is the project's overview page. You see here I use Domino quite a bit. I have a lot of projects, but I also have access to projects that people have shared with me from my team member in other organizations. And of course, you can see here at a quick glance if my last run of my model in this case was successful, when I last executed it, and if anyone has any existing runs. And all work is done inside of projects. Projects are really just a combination of files and settings, as you'll see here in a second. So I'm going to click into the wine quality project I have here. And just a quick background, this has got some code that we built that takes the chemical composition of wine and scores it against test data or a test set and predicts the quality of wine based off of things like the sugar content, pH, things like that. Okay, cool. So when I go into my project, I'm taken to the runs dashboard. We'll actually come back here in a second. I want to first go to the files page. And so this should look pretty familiar to you guys. This is just a list of all my files, and you'll see here things that you might have in a typical data science project. I've got some Python files. I've got a folder for my results. I've got some R code as well. I've got CSV data for my training data set. And if I want to document this as well, I can have README files in Markdown or HTML or plain text files. And of course, I can just come in here and edit any file in the web browser, or use the command line interface to use the IDE of my choice, like PyCharm or something else on my desktop. Everything is version controlled, and I'll show you that here in a bit as well. Where Domino starts to become not similar to what you're working with right now, and of course better, is when we go into the settings tab, where we are tracking more than just the files you have today. So on settings, we see two main sort of levers at your disposal here. We have hardware tier and compute environment. And so compute environment is really, in a nutshell, basically the software and the dependencies that you want to have installed alongside your code. So for example, here I've got a few examples. So I might have an environment for Python 2, an environment for Python 3. Right now I have a legacy version of R because I know my code works there. And of course, there's global environments, and here I'm just going to use the default. But it's really easy to change which version of whatever code that you want or whatever dependencies you want to have by just choosing the dropdown. And the rule of thumb is really that if you can install it in Linux, it can be installed inside Domino. So this really sort of subsumes the existing servers you disparately have, RStudio Server Pro maybe, Anaconda distributions, Shiny, Flask, other web servers, Jupyter. All of that can be done inside of a compute environment, and 99% of the time, you can just use the open source equivalent. You don't need to use the enterprise license that you might be spending money on. And unlike on a local computer or a shared server, you can have multiple versions of the same type of thing. So here I've got Python 2 and Python 3. So I can test my code. I know it works on Python 2. I can switch it over to Python 3, see if it works, and if not, I can always switch back. Of course, you can fork your projects and have multiple copies as well, so that you don't mess up production when you're testing your code. So that's compute environments in a nutshell. If you can install something on Linux, you can install it on Domino, and we'd be happy to go into more detail with you one-on-one if you have specific questions. The other drop-down we have here, which is extremely important because software and dependencies is not enough for data scientists to do their work well and efficiently, we have hardware tiers. And basically, and this demo is running in Amazon Web Services, but it works very similarly if you have a bare metal server in your data center, is that we make it really easy for a user to choose to run their code on the size of machine that they want. So here I'm using a pretty puny half-core, half-gigabyte of RAM machine, but I can really easily, at the click of a button, decide to run my model, my training model, on a 128-core, nearly 2 terabytes of RAM machine. I'm going to switch that back just to be safe. There's lots of other settings here I don't have time to go into all, but I want to briefly show access and sharing. Projects default to private no matter what, but you can make your project public to anyone within your enterprise, in this example public, or you can make it so projects are searchable, so people can sort of search for H2O or Anaconda or RStudio or Shiny and see who else in the organization is working on a specific type of technology, and then sort of ask for access to that project so that they can learn how someone else in the organization is using that tech stack. Of course, you can invite specific people as well, so I could have my project be private and invite specific people such as my coworker Tim here, or add the whole Domino team by just adding a full organization. Awesome. Let's get to actually running code because that's also, of course, a core tenet of what Domino allows you to do. And so I'm going to go over to my runs dashboard. And because this is an existing project and I've already got some code in my files tab, I'm going to actually start up an RStudio session really easily and quickly and take a look and show you some of the code. So to start an RStudio or Jupyter or other type of interactive session, we just go to the runs dashboard and then click on the type of notebook we want, in this case RStudio. And what Domino is going to do is it's going to look at the compute environment that I chose, and it's going to look at the hardware tier. It's going to match those up, and it's going to send the copy of my files in the Files tab over to a server of the right size and install all the dependencies that I need for them. So in this case, I believe I'm running R32 and Python 2.7, and it's going to give me some output, keep me updated on the progress, and just like that, it gives me this nice green Open Session button where I can click on Open Session, and I'm going to be taken to RStudio in my browser. It's going to look exactly like, if you guys are familiar with RStudio, it's going to look exactly like when I run it on my local machine. But again, this is not running on my local machine. It's running on a beefy server that Domino is managing for me, and all of my dependencies, Python, R, Conda, what have you, have already all been installed. So I can go into my code just like I normally would. Here, actually, I'm going to go to predict.r, and I can just start running my code as I normally would, and I'm going to predict the line quality of, in this case, these integers that map to different values. And so this is RStudio. In a matter of seconds, I went from not having a server, I sort of was saving money without having a server running, and now I have a server running just for me with RStudio in it. You might notice here in the address bar, we are doing all of that complicated reverse proxying that you or your IT team would need to do on their own. So even if I copy this URL and put it into an incognito window, it would say unauthorized because everything is being authenticated, and you don't risk sort of having these EC2 servers I've seen in other companies sort of just running in the wild and have them open to the public, hoping that no one guesses the IP address and port that you happen to be running your sort of random RStudio session on. So that's pretty important, especially in large organizations, of course. Just as well, I could start up a Jupyter session. Again, I could be running these actually simultaneously, and I can name them however I want. So while I'm working, I invited Tim or maybe my boss to this project, and I can rename and say, hey, I'm evaluating the wine quality model, and sort of give my coworkers a heads up of what this running session is and what I'm doing. I can also go into the discussion tab and give a little bit more detail, and I can tell Tim, like, hey, this model looks good, let's send it to the QA team. And so this is part of the collaboration, and you can comment and rename things such as runs, as well as tag them, such as maybe we're going to say that this one's ready for QA. And we could have an email sent off to the QA team and say, hey, it's time to actually come in and validate this exact version of the model. You might ask, how do they know exactly which version of the code? Because I might have been changing the code from time to time. In the Details tab, there's a really easy link here to the input files of this run. And so they could click on View Input Files, and come to the exact version of the files at the exact time that I started this run. All right. So I also just want to show real quickly, I know we might have some, that was RStudio real quick. Jupyter Notebooks works exactly the same way. I can click on Open Session and I have Jupyter Notebooks, and I can start a notebook session in the place that with the notebook type I want. So this version has Julia and Python, R, and Scala all installed. And again, in these compute environments, I can upgrade these side by side, so I can always have the version that I want, but archive the old versions, so I don't have to worry about being able to go back in time or remember exactly what commands I ran. Everything is versioned for me, not just the code, but the results as well as the compute environments. So I ran these. It's really easy to stop these from running. I can just click on stop, and it's going to save all of the changes that I made in my interactive session. I noticed here that maybe if I'm a new user to this project, I notice here that someone, it happens to be me, but we've been running train trees.r with it followed by an integer. So even without having to read a huge README or documentation about how to actually run this project, just by having this runs dashboard, it's sort of a lab notebook, if you will, a history of everything we've done, I can see that, I probably want to run train trees.r followed by an integer, and it happens to be the number of trees to traverse and calculate the prediction model. And what I can do is, as opposed to those interactive sessions that just kept running, I can start up a batch session or a batch run of my code by just clicking on run and typing train trees.r. I'm going to kick it off for 100 trees, and at the exact same time, I'm going to start it up to train two branches of the tree. And so you see that this model is running. I can check the status of the output, SSHN, even if I needed to check on it. And this one is done, so I'm going to go and view the results. And the results is basically just a fancy word in Domino to denote the difference between the input snapshot of all the files and the output snapshot. And so that delta is what we call the results. And so we've got some diagnostic output here, and then I had my model output a chart, and we've got the standard out. If there was an error, I could go ahead and debug that. Going back, you can actually comment on, again, the whole run or experiment, if you will, or you could leave a comment to someone just on a specific asset. So cool. All right. One of the nice things with Domino, again, I was running these two pieces of code simultaneously. What I can also do is, since Domino is taking snapshots before and after each run, is I can go and start to compare these different runs with different parameters. So I'm going to take, for example, this train trees R with a model with an N of 200 and an N of 2. One nice thing I'll just point out real quick is that Domino has this idea of diagnostic statistics, and so even without going and clicking in and reading all of this to see what the output was and looking at the chart, I can really quickly see that my error rate actually improved, assuming lower is better, of course, by going from 2 trees with a 0.671 to 200 trees with an error rate of 0.585. So that's a really simple way of just being able to scroll through and see what the output or what the KPI for that model was. So again, I just clicked the checkbox next to both of these runs. I can go up here and click on compare. And Domino is going to show me a side-by-side comparison of these two different runs with all the provenance and all of the results and what exactly changed. So we see here, run number 16, I did train trees.r with a value of 2. And then here on run number 17, I have train trees.r with a value of 200. And it gives us visual cues. It says that both of them succeeded, all that good stuff. We can see exactly what changed in terms of the diagnostic statistics, the input and the classifier data. And then here we see, again, I was outputting these different charts. And here we can actually start to overlay these images. And we can see how this output actually changed over time. And so this, especially if you're doing consistent charts with the same axes, this is really helpful to see how you might have improved or maybe regressed. And of course, if you want to go back to your files and revert to an earlier version of those files, that is extremely easy to do as well. The fact that you can revert files back and forth, and I'll just show that to you really briefly by going back to this run, is extremely important in regulated industries like financial services and life sciences. This is absolutely critical. So the fact that you can actually go back in time and see what exactly ran and what exactly the input and the output was, and who ran it, what time it was at, what the input, again, what the output was, and be able to revert back and forth is extremely important, especially in these regulated industries that I know some of you guys are part of. There's a lot of other features I'd love to actually show you guys about Domino, but it looks like we're starting to run low on time. I want to just show a few more things, and of course, feel free to ask questions. There is a very interesting and robust set of functionality of taking these models that I was just showing you, that I was running one-offs, and actually productionize and operationalize these into deployments for the rest of the organization to use. So we can actually literally take that traintrees.r file and create an API endpoint off of it by just telling the code file as well as the function. I believe it was the predict function. And we can really easily publish an API endpoint, and it'll give us an example of how we can run or how we can call this API endpoint. It's a RESTful API. No sort of DevOps or web developer knowledge needed from your data scientists to call this API in whatever code the rest of your application, your engineering team might be using. So whether it's Java or PHP or Ruby, what have you. There's also functionality, of course, as I mentioned, to publish Shiny and Flask and really any sort of web app here within Domino. So you can publish interactive charts and things like that, as well as some functionality we call launchers, where you can create this nice GUI for someone who might be a little less technical to come and actually start a run of maybe the train trees model with a value of 10 without having to go in here and clicking run and knowing exactly what to do. It's a bit more of a guided experience for that type of user. And so with that, it looks like we've really just got a few more minutes left. I really want to appreciate your time. Really want to thank you for your time today, and really enjoyed talking to you about how you can use these open source tools on top of Domino. And with a few minutes that we have left, I'm going to take a look at the questions we've answered and see what we can answer for you guys. So thanks again, and feel free to put your questions into the question box. Okay, cool. So we've got a few. First question is, I talked about large enterprises, organizations a lot. You know, this person asking the question is asking like, so who are you referencing? And so I can't say all the names, but I think the best place to go is if we go to dominodatalab.com. I could talk you through some of the industries that we primarily work with and can talk about. And so here, again, this is just dominodatalab.com. We've got large insurers from Zurich and Allstate to credit rating agencies like DBRS, startups from Lumosity and Instacart and Mashable, and consumer packaged good and life science companies like Clorox. And of course, we've got Monsanto as well. And so our customers run the gamut. They have usually more than just a few, but also sometimes just a few data scientists. They're working either distributed across different teams or maybe all on the same team in a center of excellence. And they need tools to collaborate and make sure that their research and their work is reproducible. And so those are the use cases that we tend to see the most. If you have any questions about like specific industries or like life sciences or pharma, we can certainly get you some use cases and white papers via email as well. Okay, and someone is asking, you know, I talked about compute environments, and a lot of this is about compute environments, right? What does that actually look like? And so that starts to get a bit into the weeds, but I'd be more than happy to sort of talk to you about that really briefly. So if we go back to the settings page, again, settings is where you can choose both the software that it gets installed alongside the code in the Files tab, but also the hardware is you can choose the hardware tier, again, scale it up and down. If we want to actually look at the environment definition, we can click on Manage Environments. Let me take you guys to an example. Domino, in some ways, is an abstract, in terms of computer environments, we abstract a lot of the hard parts of Docker, which is basically, in a nutshell, containerization framework. And so creating a compute environment can be as easy as entering a shell script saying, pip install spacey, but you can also take advantage of some of the power of Docker by creating a Docker file in Domino. And so here I'm just saying, hey, I want to create this Anaconda 3 environment. I want to actually build upon this base image of Anaconda, and I want to install a new environment that has Python 3.5. Similarly, here I think I've got a spacey example, or here this RGL example, which is an R package. You can really easily make sure that every time you run your code that you have the latest version of R from CRAN. Cool. Got a few more questions. How about the storage of data? Is this on cloud or on-prem, and how many types of databases can be connected? That's a great question. So depending on how you decide to deploy Domino, we've got a few different ways. It can be in a virtual private cloud, or it can be on-prem on your bare metal servers. So your data will be stored however you want it to be stored. It can be on S3, or it could be on a NAS drive or a SAN that is in your local data center. We have deployments that are completely offline and separated from the internet, and so we do, just to be clear, we do completely on-prem solutions as well, especially when security, of course, is of top concern. And so the follow-up question to that was how many types of databases can be connected. It's really up to you how you want to connect to those. If you can connect, you can run like JDBC drivers in R and Python, or if you want to set up something with Spark or Hadoop, we have native integration for those as well. A user was also asking about the visualization console. So basically, Domino is going to run your code, and so if your code generates a chart, we will show you that chart in the results pane. So that it's really as simple as that. If you generate like a D3 or high charts or sort of interactive visualization with HTML in your Python, your R, or your other code, we'll show you that as well in the web browser. That reminds me, just as a quick note, there's actually nothing super specific to Python or R for Domino. If you are running Scala or Java models, or I've worked with some customers writing Fortran and C code, this can all be installed in a compute environment, and we're more than happy to help you get started on those. I'm going to answer one more question, and then I think we'll have to drop off. I really appreciate everyone's time today. Good question. How much effort is needed to set up an on-prem pilot to try the solution hands-on? That is a great question. We find that it can be stood up in a number of weeks. It's we can go through details again offline, but it's really not that much effort. It is a little bit faster maybe to deploy to a virtual private cloud, but we can definitely do trials on-prem as well, and we'll definitely be sure to reach out with some details. And as you see here on this slide, you can email sales@dominodatalab.com with any specific questions. So with that, I'm going to end this webinar. Really appreciate everyone's time, and we will be sending a recording to you on Monday. And if you get a survey about how this went, please do give us feedback. We're always looking to improve. So thanks again, and have a great weekend.